Hello, welcome to the course on the Public Land Survey Systems. My name is Jim Cohn. I'm a professional land surveyor in Washington and Oregon. I'm also a certified federal surveyor. What we're going to be talking about in this course is the Public Land Survey System of the United States. The course covers the use of the public land system as a system of legal control. The topics covered include history, monumentation, area computations, section retracement, corner restoration, and subdivisions of sections. This is a very important class for surveyors, as most of the United States is surveyed under this system. Let's go to the next slide and we'll see what I'm talking about. The system started with the Land Ordinance of 1785. Thomas Jefferson was actually aware of the great potential benefits offered by land in the West. A growing population in the original states, now largely free from British rule because it was right after the Revolutionary War, was being pushed into these areas. Jefferson had earlier offered a systematic means to prepare new areas for statehood in the Ordinance of 1784. In the following year, he directed his attention to the design of a system for surveying the lands that might avoid the pitfalls of earlier methods of determining boundaries. Now, the Land Ordinance of 1785 set forth how the government of the United States would measure and divide and distribute the lands it had acquired from Great Britain north and west of the Ohio River at the end of the American Revolution. Now, what I'd like you to do is just read through this slide that you're looking at, pay particular attention to section 16 and the cost of the lands per acre. When you get finished with that, let's go on to the next slide. The term public lands applies broadly to the area that have been subject to administration, survey, and transfer of title to private owners under the Public Land Survey laws of the United States since 1785. That is, it's what we're going to do. We're going to survey the land, then we're going to be able to transfer it from the federal government to the private owner. That's what this system helps us do. And so we have to understand about the system and how it all works. 30 states, including Alaska, constitute the Public Land Survey states, which have been or will be subdivided into the rectangular tracts. The states that are left out of this are basically the original 13 colonies, Texas, and Hawaii. So let's move on. Approximately 72% of the United States is governed by the Public Land Survey System. According to the Land Ordinance of May 20th, 1785, the land needed to be subdivided before it was sold. According to the Manual of Survey Instructions, the law provided that the public lands of the United States shall be divided by lines intersecting true north-south lines at right angles so as to form townships 6 miles square. Now remember that the township is 6 miles square. We're going to see what townships are, and we're going to see how they're divided in the upcoming slides. Townships were marked with progressive numbering from where they began. The township is going to be further divided into 36 sections, each section being a mile square, containing 640 acres as near as may be. The sections were going to be numbered from 1 to 36, with number 1 starting at the northeast corner of the township, heading west to section 6, dropping south to section 7, then heading back east to section 12, and so forth back and forth until section 36 at the southeast corner of the township. The way that this system was developed, it's called Bustrofundonic, and it literally is Latin for as the ox turns while plowing. Now that you're not going to forget. Here's a map of all the states that are involved in the public land survey system. All the colored states are part of the public land survey system. Now, if you take a look over in the northwest to where Washington and Oregon is, you'll notice that there's a north-south line called Willamette, and then there's an east-west line with no name to it. The north-south line is the Willamette Meridian. That's meridian being north-south. And the east-west line is the baseline. Now, where the two lines intersect, that's where all the surveys start in the public land system for Washington and Oregon. Now, all the other states that you see on this map have similar baselines and meridians with different names and for different states. For example, if you look down in Arkansas, you'll see the 5th meridian and the baseline down in Arkansas. That meridian and baseline controls surveys from Arkansas all the way up into North Dakota. So you can see that it's quite a lot of land that that those meridians control. And all of these other meridians and baselines control different lines across the United States. You'll notice that at the intersection there's dates, like in the Willamette Meridian in Washington, Oregon, it's 1851. That's when the survey started. So that's what this map is showing you, and you can see all of the public land survey states and all of the states that are not part of the public land survey system. As we said before, the United States Public Land Survey System, or the PLSS, was inaugurated in 1785. And the territory that's now eastern Ohio served as the test area for the first surveys in the PLSS. And this area was known as the Old Seven Ranges. What you're looking at is the plat of the original surveys of the Public Land Survey System. You'll notice that on the east side, you see the Pennsylvania line. That's the west boundary of Pennsylvania, where it intersects with the north shore of the Ohio River. That's where the survey started. Then they went west for 7 ranges. Now, a range is the north-south block of townships. And so you can see that they go out quite a bit. And then they're numbered a little bit differently than we've been talking about how sections are numbered now. If you take a look at figure A on this map, you'll notice that the sections in this township, that's a figure of a township, you'll notice that the sections start with section 1 in the southeast corner and go north to section 6. And then they come back down to section 7 and go north to section 12, so forth and so on, to section 36 in the northwest corner of the township. Now this changed very quickly. This is what they originally started out with, but this changed quickly. But this is the beginning. This is the first survey of the public land survey system right here. When this system was first developed, the Surveyor General of the United States would write instructions to his surveyors in the field to explain to them how to do a particular survey in that area. Now, as the system progressed, they went from just writing instructions to individual surveyors to creating manuals. And the first manual was written in 1855, and actually it covered the surveys for Washington and Oregon. Later manuals were issued in 1881, 1890, 1894, 1902, 1930, 1947, 1973, and the current manual is 2009. The reason that they made all these manuals is because the system became more sophisticated as we got more involved in the public land survey system. The way they measured townships and sections was using an instrument called a chain. The distance given in the instructions were in chains, and one chain would equal 66 feet. And it was called a Gunther's chain. This is what a Gunther's chain looks like when it was all rolled up or when it was put together. You'll notice that they have these little wire pins going back and forth. Those things were called links, and there was 100 of them to make up a Gunther's chain. And in the next slide, you're going to see the genius of this system. So let's go on to the next slide. The chain was selected because one chain equaled 100 links. Now, that means that the chain was 66 feet long, so one link would equal 0.66 feet. But here's the genius of it. 80 chains would equal 1 mile. 10 square chains would equal 1 acre. And one chain would equal 4 rods. And one rod equaled 1 pole, which equaled 1 perch, which all equaled 16.5 feet. Now, depending on where you were in the country, they would call these distances rods, poles, or perches. Here in the Northwest, you can see them called all three of those things depending on the survey. But this is what the system of measurement that they used for determining distances. What I would like to do now is just go over some measurements with you so we have an understanding of what we are dealing with distances. And this is going to be metric conversion to the United States survey foot. There's several different kinds of foot, so let's just take a look at what we have here. 1 meter equals 39.37 inches, and that's an exact measurement. 1 U.S. survey foot equals 0.304800696, and the decimals go on forever, meters. 1 link equals 0.2011684023 meters, and 1 meter equals 3.2808333, and that goes on forever, a U.S. survey foot. 1 acre equals 0.404 and a bunch of other stuff, hectares. Now, what a hectare is, it's 1 kilometer by 1 kilometer. And it's the area, it's similar to what we call acres, but that's used in the metric system, and it's called a hectare. And it's much larger than an acre. 1 hectare equals 10,000 square meters. So you can see that it's going to be much larger than what our acre is. Let's take a look at some more of these measurements. Now we're going to take a look at metric conversions to the international foot. The international foot is different than the U.S. survey foot. Now, the confusing part about this, some states by law say that surveyors must use the U.S. survey foot, but in other states, they have to use the international foot. This is true in Washington and Oregon. In Washington, it's the U.S. survey foot. In Oregon, it's the international foot. And there is differences, as we're going to see. But if you take a look at our list here, 1 inch equals 25.4 millimeters. That's exact. 1 SI foot. Now the SI stands for Systems International, and that's the international foot. That equals 0.3048 meters exactly. If you compare that to the US survey foot, you'll see the difference. 1 meter equals 3.2808 and a bunch of other decimals, Systems International foot or international foot. So they're the things that we wanted to show you. They're in the Manual of Survey Instructions 2009, and we just need to be aware of it. But you as surveyors pay particular attention to the US survey foot versus the international foot, and make sure you're using the proper one for your calculations and your particular state. Now, when you're working in the public land survey system, you're going to be using the US survey foot.
But before you do, I would suggest to you that you download the PDF file for the second lecture and you keep that with you so you can take notes.